Let's say that we have the linear equation y is equal to 1/2 x, 1/2 x minus 3. So if we wanted to draw the line that represents the set of all points, all the coordinates where the x value and the y value satisfy this equation, well, we could start off by just trying to draw, by trying to draw a few of those points and then connecting them with a line. So let's set up a little table here, x comma y. And then we could just try out a couple of x values here, and then figure out what the corresponding y values are. And I'm going to pick x values where it's going to be fairly easy to calculate the y values. So let's say when x is equal to 0, then you're going to have 1/2 times 0 minus 3. Well, then y is going to be negative 3. When x is, let's see, let me try x is equal to 2, because then 1/2 times 2 is just going to be 1. So when x is equal to 2, you're going to have 1/2 times 2 is 1, minus 3 is negative 2. When x is equal to, let's try 4. So 1/2 times 4 is 2, and then minus 3 is negative 1. And we could keep going, but actually all we need is 2 points for a line. So we're ready to plot this line if we'd like. The point 0, negative 3 is on this line. 0, negative 3. And actually let me do this in a slightly darker color so that we can see it on this white background. 0, negative 3 is on the line. 2, negative 2 is on the line. So 2, negative 2. And then we have 4, negative 1. So when x is 4, y is negative 1. And I could draw a line that connects all of these. So it would look something like, let's see if I can do this. So it would look something like that. So this right over here, this is the graph of y is equal to 1/2 x minus 3. Now when we look at a graph like this, an interesting thing that we might want to ask ourselves is, where does the graph intersect our axes? So first we could say, well, where does it intersect our x-axis? And when you look at this, it looks like it happens at this point right over here. And this point where a graph intersects an axis, this is called an intercept. And this one in particular is called the x-intercept. Why is it called the x-intercept? Because that's where the graph is intersecting the x-axis. And the x-intercept, it looks like this is at the point 6, 0. Now it's very interesting. The x-intercept happens when y is equal to 0. Remember, you're on the x-axis when you haven't moved up or down from that axis, which means y is equal to 0. So your x-intercept happens at x equals 6, y equals 0. It's this coordinate. Now what about the y-intercept? Well, the y-intercept is this point right over here. This is where you intersect, or I guess you could say intercept, the y-axis. So this right over here, that over there is the y-intercept. And the y-intercept is at the coordinate that has a 0 for the x-coordinate. X is 0 here, and y is negative 3. X is 0, and y is negative 3. This was actually one of the points that or one of the pairs that we first tried out. And you can validate that 6, 0 satisfies this equation right over here. If x is 6, 1/2 times 6 is 3 minus 3 is indeed equal to 0. So now that we know what an x-intercept is, it's the point where a graph intersects the x-axis or intercepts the x-axis. And the y-intercept is the point where a graph intercepts the y-axis or intersects the y-axis. Let's try to see if we can find the x and y-intercepts for a few other linear equations. So let's say that I have the linear equation. Let's say that I have 5x plus 6y is equal to 30. I encourage you to pause this video and figure out what are the x and y intercepts for the graph that represents the solutions, all the x-y pairs that satisfy this equation. Well, the easiest thing to do here, let's see what the y value is when x is equal to 0 and what the x value is when y is equal to 0. When x is equal to 0, this becomes 6y equal 30. And so 6 times what is 30? Well, y would be equal to 5 here. So when x is 0, y is 5. And what about when y is 0? Well, when y is 0, that's going to be 0. And you have 5x is equal to 30. Well, then x would be equal to 6. Then x would be equal to 6. So we could plot those points, 0, 5. When x is 0, y is 5. And when x is 6, y is 0. So those are both points on this graph. And then the actual graph is going to, or the actual line that represents the x and y pairs that satisfy this equation is going to look like, it's going to look like this. I'll just try so I can make it go. It's going to look like, it's going to go through those 2 points. And so it's going to, and I can make it go the other way too. Let me see. It's going to go through those 2 points. And so it's going to look something like that. Now, what are its x and y intercepts? Well, we already kind of figured it out, but the intercepts themselves, these are the points on the graph where they intersect the axes. So this right over here, this is the y-intercept. That point is the y-intercept. And it happens, it's always going to happen when x is equal to 0. And when x is equal to 0, we know that y is equal to 5. It's that point, the point 0, 5. And what is the what is the x-intercept? The x-intercept is the point, it's actually the same x-intercept for for this equation right over here. It's the point 6, 0. That point right over there.